I am Dr. S. Mahendran, Professor, Department of Civil Engineering, PSN College of Engineering Technology, Dindigal. I welcome you all to today's discussion on the subject Engineering Geology. And in this session, we are about to discuss the most important chapter in the engineering geology, that is mineralogy. Mineralogy is a branch of geology which deals with the individual properties, the mode of formation and mode of occurrence about various minerals on the earth. And now we will discuss about the basic things about the minerals and how the minerals can be classified based on the type of minerals, and the classification of mineral is done with the identification of individual minerals, and that is to be done by the observation of the individual properties of the mineral. So today's discussion will be mainly focusing about what is a mineral, what are the types of minerals, and what are the properties that can be useful for us to identify and classify the minerals and to understand the purpose of the mineralogy. That's what we are going to discuss. If you want to study the minerals in detail, or if you want to have a proper understanding of mineralogy, it is better to have some little bit exposure about the nature, formation and evolution of the earth to this present state. Since from the origin of the earth, it was evolved from a gaseous molecule or a piece from the sun. It has no solid surface. After some time, due to the cooling, the outermost surface of the earth becomes solid, and it forms a thin layer that is made up of it is identified as the crust, and it is made up of the solid block, the units of the earth crust. It is called as the crust. So the earth crust is made up of rocks. What we are going to discuss about the minerals are the units that forms the rocks or the crust. So the minerals are available on the earth's surface. Whether the minerals can be artificial, by no means the minerals can be produced artificially. They are the most essential resource available for the mankind on this planet Earth. So we shall define what is a mineral now. At this point, we can say that the minerals are naturally available. It is all the minerals are naturally available or natural, and all the minerals are solid, and the minerals cannot be formed by any organic process, that is by means of the burial of vegetation or by means of animal, that cannot form a mineral. It can be formed by the inorganic process. So minerals are naturally formed, and it is inorganic, and they have a solid, and they are really homogeneous in nature. Homogeneous solid substance. How the minerals can be a solid one? Because each and every minerals have its own chemical composition, and that chemical composition determines the basic atomic structure of the mineral. So that gives a definite structure as well as a solid nature of the mineral. So a mineral thus formed in the inorganic way can be a solid substance and homogeneous with a definite definite chemical composition. That chemical composition makes the regular atomic structure of a mineral. So this can be taken as a simple definition of a mineral. Again, I am repeating: minerals are naturally available, inorganic, homogeneous, solid substance which has its own chemical composition and a regular atomic structure. So this makes the individual properties of the minerals that can differ in so many ways with different engineering properties, and that is true for the different formation of the S surface. Now, the minerals can be classified based on the occurrence. See, no minerals can be available in a single state. It is only available in associated with the other minerals. For example, any mineral, say for example the important ore minerals for a metal like copper or aluminum or even gold, they cannot be available in a single state. So they will be always associated with the other minerals, maybe more than two or else. So these mineral assemblages are known as the rocks. They are the basic building blocks of the earth crust. Now, more than 2000 minerals have been identified so far. Still, very few minerals form the surface of the earth, that is the earth crust. And often, very few minerals are represented in the rock types. So these minerals are known as the rock forming minerals. Rock forming minerals are rock minerals. Then what about the other minerals? These, regarding the classification, apart from the rock forming minerals that is abundantly available on their surface, some minerals have a significance due to its own industrial use as well as the economic use, and they are not abundantly available. Still, we have to search for the mineral and for their occurrences and the availability. Those minerals are mostly the ore minerals for the metals. Ore minerals for the metals. And still, some of the minerals are very rarely available, and still due to their demand and their less abundance, they have more significance and they are recognized as the rare minerals or rare earth minerals. Let us see a few examples for that. The common rock forming minerals are quartz, feldspar, etc. And the ore minerals, the common example can be their ore or the alumina, that is the bauxite, and the ore for the iron, their magnetite, hematite, etc. The rare minerals include the very precious diamond. The common example can be a better example. Diamond is the rare mineral. So we have seen the definition of the mineral and the basic classification of the minerals, rock forming minerals, the industrial ore minerals. The ore minerals have the industrial importance. Most of the ore minerals are the source for the metals, and that is very much essential for the development of industry and the growth of economy in the society. And some of the minerals that can be used as the ornamental purpose and any other importance, they have still higher economic value. So in general, the minerals are the only natural resources that can determine the status and development or growth of any country. Now, this classification can be done based on the identification of the minerals, and that identification is possible only on the properties of the minerals. Now we will discuss about the properties of the minerals. The minerals have three important properties. First of all, a mineral can be studied by the physical observation, merely having a specimen on the hand, and those properties are called as the physical properties. And some of the properties we have to go for the very detailed observation under the microscope. They are known as the optical properties, and some of the properties that is very essential to confirm certain minerals. They can be done only under the clear thorough investigation at the laboratory. They are the chemical properties. So apart from the optical properties and the chemical properties, physical properties are more easy for us and convenient for us to identify most of the minerals. We will see what are the physical properties that can be observed and used for the identification and then for the classification of the mineral. So today we will be getting more onto that, the physical properties. The physical properties, first thing is what we can observe microscopically on the mineral. I would like to show some of the samples of the mineral. So this is a very commonly available mineral, and you can see the basic property of the mineral, and when compared to the other minerals, these are also a specimen of few minerals. Most of the minerals are colorless in nature. The very first property that we can recognize from a mineral is the color. When compared to this mineral shows somewhat pink color, this is black color, and this is white or almost transparent mixed with the black. Let us see. This is the first property that can be identified from any mineral. So we will see what is that property. So now we can define. Color is the physical property of a mineral. That is the observation of mineral or the behavior of a mineral on the light. So it depends whether the minerals can be colorless or it can be completely black. It depends on the optical property of the mineral, that is the reflection and refraction of the minerals of the light on the particular crystal lattice of the mineral. The particular portion of the light can be observed and particular portions can be reflected. That makes the color property of a mineral. The name of this mineral is quartz. Basically, this quartz mineral is highly transparent and colorless. So that's a common example for the colorless mineral is the quartz. Colorless can be a specific example with the mineral called the quartz. But here this mineral is showing somewhat pink color, whereas the same quartz is colorless in this specimen. So what's the reason for that? Under the property color, we can observe some important properties that is meant for the specific minerals. And some of the minerals, that is for the metallic ores like copper, the minerals like chalcopyrite or cuprite, they will have typical coloring property resembling the metallic brass. So the color of this mineral will be easily identified from the field with a bronze yellow or a very copper yellow. So the best example for those minerals can be described as it is the ideal color of the mineral, that is the ideochromatic. Ideochromatic is what is the basic term to describe ideochromatic is, the best example is the copper mineral. You just imagine the mineral copper, what is the color? Typical bronze yellow. So it is the constant color. The ideochromatic is the constant color, and it is due to the chemical composition of the chemical composition of the mineral, and it is mostly described by the mineral of metallic nature, and a very typical example is the copper mineral, that is the cuprite or chalcopyrite. This is the idiochromatic. So the mineral itself can be identified from the first property itself, that is the color itself. Very few minerals can be confirmed by studying their color property. Rest of the minerals we have to go for the other investigations to confirm whether it is belonging to that category. Now, some of the minerals, very basic example I have already mentioned, that quartz minerals are colorless. Still, some of the minerals, they can show some colors even though they are colorless by nature. The very typical example is the mineral, again the quartz. This is also the quartz, whereas this mineral is also quartz, basically colorless nature, but here it shows the pink color. So this quartz is termed as the rosy quartz. So here the color is due to the addition of some of the materials, some accessory minerals, they are called as the coloring impurities. So the second category of this color is called as the allochromatic. Allochromatic means here it is not the constant color of the mineral, it is the variable color. The color is variable, and it is due to it is not due to the chemical composition, it is due to the coloring impurities. It is due to the coloring impurities, and they can vary. It is completely dispersed. It is thoroughly dispersed along the entire mineral in composition. It is dispersed thoroughly. So this is not the original or idiochromatic color. This is called as the allochromatic. Here, to describe the color property of the mineral, we are using the term chromatic. So remember that it is very easy. Idiochromatic is the constant color, whereas allochromatic is the color of variable nature due to the coloring impurities. Here the titanium oxide is completely dispersed. This is a coloring impurity. It is dispersed in the medium in the quartz. So the quartz is become rosy quartz. And in some other cases, what happened? It is not the idiochromatic or the allochromatic. It is the third category, that is called the pseudochromatic. Pseudochromatic means it is not the original color. It means it is a false color. False color means if you give a rotation, the actual look or appearance of the color of the mineral may be changed. So on rotation it may be changed on rotation. How it is possible? If the coloring impurities are mixed thoroughly with the medium, it can have a same single color, but like a glass paper white, here and there some inclusions may be there. So it is due to the inclusions of the impurities. Inclusions of coloring impurities will be there. So here and there some inclusions may be there. So when we have a rotation of the specimen on hand, it will show some variable color that's not at all related to the composition of the mineral. That's called as the pseudochromatic. And another property of another category of the color is iridescence. Iridescence is the property that is like a few drops of oil when spilled over the water, it will show a color ranging like a rainbow. This rainbow color can be obtained when a few drops of oil spilled over the water. So that kind of reflection, a complete reflection is possible on the surface of some minerals. A very typical example is the mineral labradorite. Now, apart from this, on the field, some of the minerals may not show the true colors. It is not at all related to the chemical composition or any accessory minerals, form as impurities. It may be due to some other reason. Again, with the mineral ores of the metallic elements, the copper, especially the copper ores, due to the oxidation and in the atmospheric condition, the outermost layer or outermost color, the outermost layer of the ores may be changed due to the oxidation. So that property or category of the color is called as the tarnish. So tarnish means it is the external color or external color change due to the oxidation. It is mostly related with the metallic element, especially the copper ores. These are the important category for the classification of color. Apart from that, very few minerals can be identified or even confirmed by their color itself. Say for example, some of the gemstones are there. A very typical gemstone, beryl, is identified by the typical green color, and some of the gemstones, they are colorless, like the diamond, they are just totally colorless, and this colorless diamond can be further confined with its own peculiar property of the color. That is, in the diamond, a complete total reflection will be happening with the light, so it seems colorless. But when we have a complete rotation of the diamond on our hand, we can observe the development of a series of changing colors, and the color may be changing beyond the complete rotation, and the rate of changing will be very rapid. So the diamond is identified by the colorless nature, and the rapid changing of series development of colors, and that property is called as the play of colors. The similar properties, this is meant for the diamond, and no other mineral is having this kind of property. Whereas the same property can be observed in some other mineral also. That is, you can observe the change of colors, but the change of colors will not be that much rapid, somewhat slowly in nature. So instead of play of colors, you can change the change of color, and the mineral is the calcite. The variety of calcite is called the labradorite. It is called as the labradorite. It is similar to the characteristics of the diamond with the color. So the first property, physical property to identify or describe a mineral is the color. By the mere observation of color itself, we can identify very few minerals. Again we are recollecting the points. Quartz is a colorless mineral, and diamond is also having a colorless mineral. Whereas some of the gemstones are typically identified by the typical color, like a emerald or the beryl with the green color, and the lapis lazuli with the lazuli blue in nature, like that, and topaz with the yellow color. And next to the property color, what we can observe from the specimen is the shining of the mineral. Again, it is the property observed under the light. some of the minerals have a very good shining, and very few minerals have they are absent in that shining property. So the next property is the shining of the mineral, that is called as the luster. It is the shining of the mineral, shining of a mineral, and it is related to again the refractive index of the mineral as well as the crystal lattice and their position, and it depends on the surface of the mineral as well as the angle of incidence of the light. So many parameters which are there. For our convenience, we can describe the property luster in a very simple way. That is, here the luster is quite similar to that of glass, whereas I will give you some other material. This mineral has also the shiny property, but it is not that much prominent. It is somewhat dull, but we have to describe the luster. So what we can do is, we are just expressing it in a comparative way. So this luster can be compared as similar to the luster or shining of a glass. So this luster is called as the luster similar to the glass. It is called the vitreous luster. It is like the shining of a glass, right? So this is not that much vitreous. So what we are going to do is, we are using the successive other materials to compare. If the luster is next to the category of glass, maybe silk, the shining of a silk material, so it is called a silky luster. And if it is still, it is not silky, it is to the luster of a pearl, so it is called as the pearly luster. And even dull to that, we can compare the luster to the wax or resin, so it is called as a resinous luster. So luster is expressed with compared to the known object or medium, and these are the shining of the non-metallic minerals, whereas the shining of the luster property of the metallic minerals are totally referred as the metallic luster. It's just like the vessel of a metal of a vessel. Say for example, the mineral chalcopyrite will have the typical luster of the copper metal. So that the metallic luster is naturally easily identified, and these properties, these other minerals, they can be compared with the other medium, from the glass, silk, pearl, wax or resin, and finally if it is not that, it is earthy or dull. Earthy luster, say this can be the earthy luster. It is not that much prominent, so that somewhat dull than the other category. And it is very important that we cannot say that the light color minerals will have a better grade of luster. It's not like that. Even the light color minerals may not have that much luster like these kind of minerals are in the case of feldspar, whereas the dark color minerals may have also the very good luster. This luster is equal to that of glass, and this that of glass, it is also having a vitreous luster. It is dark color black color minerals called as the galena. Now the next property apart from the luster is the appearance of the observation of the physical appearance of the mineral again, that is the surface, the external appearance of the mineral on the particular angle, that is called as the fracture. Fracture means what is the appearance of the mineral on the broken surfaces. That is a simple term. How it appears. This regarding this quartz mineral, it is somewhat very sharp and angular at the edges. But when we feel at the broken surfaces, we can feel that somewhat concave nature or conchoidal nature. So this fracture can be described as the conchoidal or subconchoidal to conchoidal nature. It is for the mineral quartz. Some of the minerals, the fracture surfaces may be very sharp and irregular, so we can mention this as irregular. Like that, the fracture surfaces can be identified. After that, apart from the fracture, a very typical property that can be helpful for the identification of certain minerals is the appearance of the surfaces other than the fracture surfaces, that is called as the cleavage. I will show you some of the specimens which has a very good cleavage property. Cleavage means whenever there is a force applied to that mineral, maybe the external force, the mineral will tends to break naturally. So what will happen? Just have a look at this specimen. It has a regular shape of rhomboidal shape, and whenever it is subjected to any kind of pressure or external forces, it will deform in the particular shape only. It is a rhomboidal shape. Similarly, this mineral is a mica. When we apply any force, it will tend to break along certain direction only, like a parallel sheet. You can observe this. Even if you apply pressure, it will break along certain definite plane. So that property is known as the cleavage. So cleavage is the tendency of mineral to break along certain definite places. It will not break in any other direction. Even though forces are applied in any form, in any manner, or any direction, the minerals will have always a tendency to break along a particular direction only. So that property is called as the cleavage. It is quite different from the fracture. The minerals like this mica have the most perfect cleavage. So here the cleavage the property can be described like with the terms of comparative term, very prominent or basic cleavage, or good, perfect, like that terms can be used to describe the property cleavage. Now, the color cannot be diagnostic property to confirm particular mineral. Still, lesser cannot be also a diagnostic property. But cleavage can be a diagnostic property to understand or identify the mineral or the mica. Similarly, another important property of a mineral by which we can confirm most of the minerals, or we can group the category of most of the minerals that is possible, and that property is the that is the hardness of minerals. The next important property of a mineral is the hardness. Normally, it is the very simplest method and very common technique we apply in our day-to-day life to test the property of any material or substance or mineral. So what is the hardness? Hardness means whenever we apply certain force, how the mineral will behave. That is the resistance offered by mineral against any action of external deformation or any forces that is responsible for the external deformation, how the mineral behave. So that describes the property hardness. How it can be tested? Again, very simple. By testing with the object of known hardness value. Say for example, the hardness of our human nail is supposed to be 2.5 and the hardness of a glass piece is 5. A hardness of the metal coil is 6. Like that. If you could be able to scratch the material with our human nail, the hardness may be less than 2.5, and if it is resistant to that, and we can make the scratch by means of a glass plate, the hardness may be equal or less than 5, or the scratch can be made not by the glass plate or only with the metal coil, it can be more than 5 and to 6. So this is a simple technique, and it was regulated and effectively formed by a geologist, that is F. Moe. He is an Austrian mineralogist. He framed a scale of hardness. Very conveniently, he has grouped all the minerals in this category, ranging the hardness value from 1 to 10. So it was named after him, and known as the Mohs scale of hardness. This Mohs scale of hardness is much helpful for the engineers as well as the geologists to identify, classify and understand the group of minerals. All the minerals from the most commonly available quartz or silica to the most precious diamond can be grouped under this category. The value ranges from 1 to 10. Previously we used some different comparative terms to describe the property. Here numerically this hardness property can be described. We will see how this Mohs scale of hardness is useful for the study of the minerals. Here the hardness value 1 to 10 is assigned to the mineral in a ascending manner. That is, if the mineral having hardness 1 is considered to be the softest mineral on the earth, and the most toughest mineral with a very high hardness value of 10 is the hardest minerals on the surface. We will see what is the softest mineral with the hardness value 1. That is, see, this is a mineral by which we can able to scratch even with any kind of material. It can be scratched by the human nail or it can be scratched by any other material. So this is the softest material. What is the name of that mineral? This mineral is called as the very common earth-forming mineral. It is called as the talc. Talc is a common mineral that we used to apply in our day-to-day life. So the softest mineral. Next, after the talc, the hardness value 2. The next mineral is again a very common mineral known to all of us, that is used in the cement industry, and it is the gypsum. So hardness value 2 is for the gypsum. 3 is the hardness value for the mineral calcite, and this is the mineral to the calcite, and the hardness value 4 is for the mineral fluorite. This is the mineral. It can be promptly exhibited by the very clear solid crystal phases. That is a fluorite. And 5 and 6 are the hardness value for the feldspar group of mineral. 5 is the hardness value for apatite, and 6 is the another group of feldspar minerals. There is the orthoclase. Okay, now the 7 value for the hardness. The hardness value is 7. The mineral having this hardness has a wide industrial use, even in any optical device, including our clock system. The most accurate timing device, it is the mineral quartz. Quartz has the hardness value of 7. Again, remaining 8, 9 and 10 hardness values are there. These values hardness value more than 7 is meant for the gemstone. So this hardness 8 is for the mineral topaz, gemstone variety. And again, hardness value 9 for the mineral gemstone variety of mineral is for the corundum. And ultimately, the hardness value 10 is assigned for the most toughest and precious diamond. So this most scale of hardness is a very interesting and very helpful tool for the geologist to categorize and understand the various minerals and its groups. It covers all the common minerals to the rarely available precious minerals. So this is considered to be one of the diagnostic property. Hardness is the diagnostic property to identify and confirm that particular mineral. And next to this hardness property, one more property is that, again, it is related to the color of the mineral. What normally happens, again, just recollecting, some of the minerals are colorless, some of the metallic ores have typical constant color with the metal's nature, whereas some gemstones have its own color, like beryl, blue or quartz, green, or like that. And regarding the ore minerals, it is very difficult for us to identify the color, because almost all the metallic ores, like the iron ore or manganese ore, they will be dark in nature. Simply they will resemble like a black color mineral. So it's very difficult for us to understand, identify or discriminate. So in that case, if all the minerals are totally colorless, normally what we'll do, if two pen or two chalk piece are similar in color, or two sketch pen, a marker if similar in color, what we'll do, how we will test it? Just we will write it on a board and notice the difference in color. In the same way, the minerals are both looking black in nature or just scratched over the porcelain plate, and the streak mark is observed. The very good typical example for that mineral is the iron ore and the chromite ore. So that property described by this kind of observation is called as a streak. Streak is the coloring of the property. What will happen when we scratch the mineral over the porcelain plate? That plate is called as the streak plate. It is a glassed porcelain plate, very rough, and a mark will be left by the mineral. That is the streak is the color of a powder of mineral. Color of the powder of the mineral. the real color of the mineral will be black in color, whereas the same black color mineral will leave a brown color streak for the mineral chromite, and the black color streak for the mineral hematite or magnetite. So this is again an important property, especially for testing the ore minerals. Both the minerals having black color will leave a different streak mark, and it is the real powder of the color of the powder of the mineral. So this streak property is not meant for the colorless minerals or any other gemstone variety. It is only for the ore minerals. All the colorless will leave no streak mark. It is typically for the ore minerals alone. Next, after this property, we can go for some other property to further identify that mineral. It is the structure of the mineral. What is the structure of the mineral? Structure means it is the physical shape. Physical shape. Say for example, these minerals are quite massive without any shape, proper shape, whereas this mineral has a particular shape, it's a rhombohedral shape. These minerals like a very good elongated structure, and especially in the case of these minerals, they have a very flat structure. So this kind of structure is known as the tabular structure. Whereas some minerals will have the columnar structure. These are the columnar structure, and the minerals like mica, they have a sheet-like structure. So they are called as the foliated structure. So this structure can be described by means of these terms. They are tabular, laminated, lamellar, or columnar, like that. Or some kind of structure. Minerals may be fibrous nature, like the mineral called the asbestos and kyanite. They are fibrous and very massive, some of the minerals, and they do not have any shape. Next property is the form. Form means how it is available. Again, the shape, some of the minerals can be available in a massive form. Some of the minerals will be in association with the other minerals, so they can be only identified in the field. And another property that we can easily identify by the mineral is the specific gravity. Specific gravity means most of the cases the specimen available for our observation will differ in size. So what we can do is, for example, this mineral quartz is bigger in size. This is a mineral called galena. This is very small in size. Even though the specific gravity is of this mineral galena is higher than this quartz. So that is we can test it by our observation by our hand. So the specific gravity normally for the quartz is referred as the 2.5 for quartz, and if it is more than that, by practice you can find out that in galena it is more than some 4 or 5, like that. It depends on the property of the mineral. Most of the cases, all the ore minerals will have higher specific gravity, and the non-ore minerals or non-metallic minerals, they will have low specific gravity. So it can be arranged with from the value 2.5 to 7, and it can be described in a comparative term like that. Specific gravity is low, specific gravity is medium or high. Like that you can be able to identify the property of the specific gravity of the mineral. The only natural resource that is available for so many applications and the sustainability of the mankind on this earth is the mineral. And so far we have discussed the physical properties of minerals so as to understand and identify and further classify the mineral for various purposes. Let us have a small specimen of our minerals. These are the gemstone varieties. These minerals include the quartz, jasper, ruby, and so many other gemstone varieties, and they are having very much economic importance, and they are determining the market economy in the developing countries. And these minerals are the finished product of the naturally available minerals, and they will resemble in the field like this. So far we have discussed about the same minerals, and we shall recollect whatever we have discussed on this session. The minerals can be defined as the naturally occurring, homogeneous, inorganic, solid substance with a definite chemical composition and a regular atomic structure. These minerals each individual minerals are identified by their own individual properties, physical properties, ranging from the color. Some of the minerals are colorless, and some of the minerals are having constant color, like the metallic one is known as the ideochromatic, and some of the minerals are having coloring impurities, they are called as the allochromatic. Some of the minerals having false color as the pseudochromatic, and dark color minerals are identified by the streak property, and some minerals have the tendency to break along a definite direction, they are called as the cleavage property, and some of the minerals do not have the cleavage property, can be identified by the appearance of the fracture surface. And above all the minerals can be confirmed by the Mohs scale of hardness. The Mohs scale of hardness is a hardness scale constituted for all the group of minerals, ranging from the value 1 for the softest minerals and the number 10 for the hardest mineral, diamond. The scale of hardness from 1 to 10 is the talc, gypsum, calcite, fluorite, apatite, orthoclase, quartz, topaz, corundum, and diamond. So with this, I think and hope we'll all have a better understanding of the basic properties of minerals that is essential for the classification for the mineralogical studies. Thank you.